Hi guys, welcome to another class where we'll be looking at another example on the identity element. In this question we are given a set R which contains real numbers where P and Q are elements of the set R. We are given an operation, P operation Q as PQ minus P all over 1 plus Q. And then we are asked to find the identity elements. Here. We have to find the identity element of 2 of the operation. Now, in this case, we are given a value of the identity element. We have to find the identity element of 2 of operation 5. In this case, we know that what the very first thing we have to do is to get the identity element, that is, since we know that what the very first thing we know, P and Q both are elements of the set R, then I can say that if for identity element, I know that my A, let me use my P in this case, so that's what we are dealing with. We have my P operation, my identity element must give me my P again. That is the idea of the identity element. So if that is the case, it means from here, I can say that my P, if my P operation E will give me P, then comparing it to this, I can say that what my P operation E definitely will be PE minus P all over 1 plus E equals to P. Then if that is the case, then from here, to make each result of my formula, make each result of the relation here, and cross multiply, I'll have PE minus P equals to P into 1 plus E. This will give me PE minus P equals to P plus PE. I can bring this one to this other side. I have PE minus PE equals to P plus P. And then reaching here, it looks as if PE minus PE will give us 0, of which we won't be able to state any value for our identity element. But no, because we know we need our identity element as a value, we'll be factorizing our identity element out of this. So we have P minus P equals to 2P. And then we can say our E here is 2P divided by 0, where we can say our identity element. See, therefore, the identity element is undefined, because we know when we have a value divided by 0, we know it gives us an undefined answer. So we say the identity element of operation phi is undefined under set R. So that is that. And then we realize that if we don't even know, if we cannot even get a defined value of the identity element, then we cannot even apply this same identity element in order to get the identity element of 2 of the operation. So let's look at another operation under the same question, where we'll be considering another operation where we have A operation B giving us. So we know in this case we have an operation like this, and then we are asked to find the identity element of 2. So we're looking for E identity element of 2. And this is what we're looking for. All you need to do is first of all relate your identity element with the operation. You know that A operation identity element must give you your A again, and then you can easily say this is A plus 2E minus AE all over E equals to A. So if that is the case here, you can easily cross multiply here. You have A plus 2E minus AE equals to AE. Collecting items of AE, we know we'll be having 2E minus AE minus AE equals to minus 2, which will be giving us 2E minus 2AE equals to minus 2, which can alternatively be written as 2AE minus 2A equals to 2. That is when we multiply through by minus, by the negative sign, We can then factorize our identity elements from the two of them here. We have 2a minus 2. We can even factorize our 2 out of it also. We can have 2e into bracket a minus 1 equals to 2. And then we can say, dividing both sides by 2a, by 2 into bracket a minus 1, we'll be having 2e all over 2 into a minus 1 equals to 2, bracket 2a minus 1. Our 2 here cancels our 2, our a minus 1 goes out, our 2 here cancels 2. We'll be left with our e equals to 1 over a minus 1. So this becomes our identity element. But then in this case, we are not just asked to find the identity element, we are asked to find the identity element of 2. That means after getting our value, we substitute 2 for our variable, for the first variable there. We say identity element for 2, therefore identity element of 2 will now be e equals to 1 over 2 minus 1, which will now be 1 over 1, which is giving us a final value of 1. So this will be our identity element of 2. So in any case we are asked to find the identity element of a particular value, we first of all determine the identity element, that is its expression, then we substitute our value, the value we are asked to find, into that mathematical expression to derive our value for the identity element. In the next class, we'll be looking at another property of binary operation, which will be the final property we'll be looking at, which we refer to as the inverse element. So the inverse element we'll be looking at in the next class, but do well to solve more questions on all the previous properties that I've looked at in the commutative property, the associative property, the closure property, the distributive property, and the identity element. See you next class. Have a nice day.